Museum in London, and we created this kind of like a torus or donut shape structure piece using the strips of bamboo. But in this case, we laminated the strips of bamboo with carbon fiber sheet to achieve certain strengths in the material. And so like, we control this, again, like a flexibility and the strengths of the material by combining something traditional with something contemporary to achieve the structure. And I will talk in detail later, but we have been working with Japanese paper material extensively in these past few years. Compared to the Western paper, Japanese paper is made out of this mobile pulp, which has longer fiber lengths. So that means the material itself has is stronger than the Western paper, which is made out of wooden pulp, which has like a shorter fiber lengths. And we have been looking into how we can like use this material for architecture, or structure element, which hasn't been done extensively in history. So this is one of the examples we did, which is the exterior kind of public art piece for this university in Tokyo. So this is exterior piece and purely made out of Japanese paper. So of course, paper outside, it's like a really dangerous thing, right? If you have a rain, then the paper will just melt. But in this case, we experimented with this special treatment to the paper so that it will become, water resistant and weatherproof. And it's been almost 3 years since we installed this piece, and we had snowstorms, typhoon, hurricane, and all kinds of, weather severe conditions. But this is still withstanding. So I think it's quite interesting experiment we have been doing. One of the latest projects we did is this one, which again, experimental structure piece. We did for this old temple in Japan. And as you see, there's this really old temple lecture hall on the backdrop. And we have this intricate structure. But here, our focus is how to use this traditional Japanese nail in the structure. So this is a traditional Japanese nail. And one of the interesting things about the Japanese traditional nail is that the section is square, rectangular, whereas the mass-produced Western nails are often round-shaped section. And we try to utilize that characteristics in creating the structure piece. So as you see, we have this transparent polycarbonate pipe and connected with these nails. And since it has a square section profile, it will prevent the joint to be work as a hinge. So it kind of resists to the rotation, the moment. And we utilize that. And in order to utilize that, the hole for the nail shouldn't be round shape, because if it's round shape, then you can easily rotate the joint. So we developed this special shape, which will have the perfect fit for the nail. It has a dent in the center in order to prevent the nail to be pulled out. And each hole has different size, adjusting the size of the nail. And everything was digitally designed and digitally fabricated. So here's the process of fabricating. So like everything was like done in-house. So we created this special jig for the pipes. And yeah, you see that like so that like we can have like all these holes for the nails in the precise positions. And yeah, this is a mock-up. Yeah, that's Kengo Kuma here. And yeah, upcoming projects. Actually, we are now working on a couple of biennales this year. So one is coming up quite soon, Venice Biennale. We are invited to create the installation piece for Venice Biennale by the director, and that's something. I think the construction will start like pretty soon because the opening is next month. And also we are working for the London Design Biennale this year, which is coming up in this June. And again, like this is another experiment with Japanese paper material. So we are planning to have this panels made out of Japanese paper floating in this staircase inside this Somerset House, which is one of the old buildings in London. And lastly, I will just quickly introduce this. But another thing like we have been doing as a lab is this project called Digital Archive Project. And we have, so the University of Tokyo has like lots of prominent figures who graduated from the school. And we have been working with this architect, Arata Isozaki, to digitize his archive. So he got tons of drawings in this suburban area in Tokyo. And none of them have been digitized yet. But the thing is that it's been almost like 60 years since all the drawings were produced. And the condition of the paper is like really deteriorating to the point that we cannot scan anymore. So we are like really working on like digitizing them. And also like we're trying to come up with like the idea how to utilize this digitized archive materials. All right. And slowly getting into this, the title of today's speak, Excess. Well, I think like one of the reasons why I was invited to this talk today is that I served as the guest editor for this magazine, architecture magazine in Japan, A+U, which I did the special feature titled Post-Digitality in Architecture. And it is about showcasing 3 institutions around the world, which are doing lots of interesting exploration in terms of how the digital technologies can impact the architectural pedagogy. So we featured SciArc, that's your alma mater, Subin. Especially the EDGE program, like postgraduate program, where they have this program called Synthetic Landscape, which explores the new possibilities of ecosystem ecology in relation to this emergence of lots of disruptive technologies. Architecture technologies, which really deals with emerging the generative artificial intelligence, and fiction and entertainment, which is really about how to apply architecture knowledge to different industries, especially the entertainment industry in this case. And the Bartlett School of Architecture in London, They are also doing like really interesting experiments in using the game engines. They have, well, back then, like, it was quite new program they established, but they have this master's program called Video Game Urbanism Master's Program. And yeah, for some reasons, I didn't have a scanned copy of the pages, but we also featured ETH Zurich. I think like everyone knows what ETH Zurich has been doing in relation to the robotics. And the title of the issue was post-digitality in architecture. So post-digital was one of the keywords for this issue. And talking a bit about digital technology in architecture education or architecture design, I think this one here, which is from this annual publication from Columbia GSAP in 1996 or something, introducing the establishment of this paperless studio. And I think like this is one of the starting points of digital technologies in architecture education. That's where like all these ideas which led to parametric design or computational design emerged, I think. And today I won't like go into details about the history of paperless studio, but actually I did my PhD on the paperless studio. But I think like this is the starting point, and so that means this was like started in 1994 or 4, yeah, I think. So it's been almost like 30 years since the digital technology was introduced into architecture education or architecture design. Of course, I mean, there are lots of like similar precedents around that time. So this is not the only first example, but it's been almost 30 years, and I think now the digital technology became so ubiquitous. So, I think like, it was like so nice that you mentioned this quote from Cedric Price. But now I think like, since the digital technology becomes so proliferated, ubiquitous, now I think it's a time to like really think about what was the question. The technology is an answer, but what was the question? So that's something like really we need to like think about. And so that means like I think like we are not like really using the digital technology for the sake of digital technology or for the sake of technological novelty, but we need to think about the other implications the digital technology have. And now I want to now go into this notion of access. And I've been like looking into this concept of access, and have been doing the design studios at the University of Tokyo. So access, I think like we are facing two kinds of access today in this world. First is material access. So if you look around, they're full of stuff, materials. And even if you go deep into the Mariana Trench in the Pacific Ocean, you can find particles of microplastics. And then even if you go up into the air, there's this like thousands of space debris circulating around the Earth. So wherever you go, there's always this kind of full of artificial stuff, materials. And it is said that around 2020, the total amount of artificial material has exceeded the amount of natural material. So now we are living in this material excess, and this implies that this understanding that that artificial and natural are something like an opposite is no longer valid. So this concept of nature is in question. Of course, I mean, I think many of you know this word, Anthropocene. I think like, that's like one of the signals about this condition. Another excess, information excess. So it's been almost 30 years since the proliferation of the internet. And during these 30 years, we have been uploading first like text data, but later on like image data. And like after the YouTube, like, we started uploading videos. So more and more like data and to the internet. And we have been holding all these tons of data there. And that enabled the emergence of the generative AI, right? Using all this like data human being has been created and uploaded and holded into the internet as training data. And now we are looking at this emergence of generative AI. And now like the generative AI is like producing another excessive information, this time without human intervention. So, first, like, the ChatGPT, for instance, like, text data, but later on, like, with the emergence of Midjourney or Stable Diffusion, now image and video with this Kling or Sora or whatever other AI models, and even the 3D model are also generated by AI models recently. So we are facing this excess, and I think like I believe that architecture is responsible for responding to this kind of a world condition and reflect that into the practice or the aesthetics in architecture. So how do we respond to this condition is something I have been doing. And talking about like how to respond or how to comprehend the excess, I want to mention Mario Carpo, who is the architecture historian based in Bartlett, whose expertise is on Renaissance architecture. But of course, I mean, many of you know his works, but he has been extensively discussing digital technology, digital practice today in relation to Renaissance or let's say like post-arbority period. And in his book, one of his book, Second Digital Turn, he discusses about how the practice in architecture has been about information compression. So as you see, like we have been extensively working with two-dimensional projected drawings, whereas the actual buildings, actual built space are three-dimensional with materiality. But we have been like compressing that into something comprehensible, two-dimensional drawings or perspective drawings. But he argues that now, like with this emergence of technologies such as 3D scanning or 3D printing, we don't need to like compress the information anymore. So you can just 3D scan the physical object and manipulate that data and 3D print immediately so that you don't need to do any compression. But the thing is that I think it's a bit optimistic view So for those who have used 3D scanning or 3D printing, you're familiar with this, but even with a 3D scanning, you always have some errors, right? Like, if you scan this kind of a clicker, then you have existing holes in the 3D model, or if you 3D print something, sometimes you have this, how can I say, like a noodle effect, this kind of error in 3D printing. So I think it's technically fundamentally impossible to comprehend the excess as it is. And I don't want to go too much into detail, but there's this the philosophical movement called object-oriented ontology, coined by this philosopher who is based in SCI-Arc now, Graham Harman. And he argues that any object has its mysterious core, and which is inaccessible. So we cannot comprehend anything as it is. And even if even if the resolution of 3D scanning or 3D printing has been refined, I think there's this this kind of things called uncanny valley here. Slide. So this is the concept from the robotic engineering, but how can I say it? If you make the robot looks like human, to one point, the person who looks at this robot feels some kind of affinity. But if the robot becomes more realistic, then suddenly, the person will feel have a negative, emotion. So this is called uncanny valley, and I think there's something similar here too. Even if you try to grasp the excess as it is, you always fail to grasp. There's always this uncanny valley lying, and you just fall into this uncanny valley. So, but I think that's something really interesting for me, and I think there's new aesthetics lying on the bottom of this uncanny valley. This incapability of grasping excess itself is something which we need to deal with, and I think that's somewhere there's a new aesthetics hidden in architecture. So with that idea, I have been doing different kinds of projects. So again, coming back to this one, which I did for London. This is again a Japanese paper, sculpture piece, but made out of hundreds of 3D scanned elements found in the street of Tokyo and London, not strictly related to architecture. So sometimes you have pub in the corner of London, telephone booth, which I would say more architectural, but sometimes you have this kind of a sushi or bonsai tree or donut, which is not really architectural. But anyways, having lots of 3D scan models of those found elements in the street, digitally collage, and CNC mill, and using the CNC mill styrofoam as a mold, I applied sheets, layers of Japanese paper and demolded, and becomes a self-standing structure piece. And this is really about appreciating these errors or losing information during the process of 3D scanning, CNC milling, hand pasting washi Japanese paper, and creating this kind of a really mysterious, uncanny kind of object is one of the theme of this project. This is another version, the second version, which is this 2-meter span 2-meter high dome structure. So this one is like self-supporting, self-standing structure piece, which has more complex geometrical challenge light. And yeah, here's. And yeah, this is another one, which is more like a critical project. So there's this stone, the rock, random rock I found in the front of the School of Architecture, and 3D scan this and create this kind of a object based on the 3D scanned model. So again, like this is, well, I would say like a caricature of this impossibility of grasping the excess. So even though like you can 3D scan this random rock in high resolution, for instance, you cannot scan the inside, the content of the rock itself. So the 3D model you have, the scanned model you have, is always like hollowed out. So there's always like some failure of grasping the object itself, and inside this like hollow, you can insert any kinds of fiction. So that's why like from one side, there's a texture of this actual rock applied, but from the other side, there's this hairy material which is totally fake applied. So there's it's a kind of critical project which argues for this impossibility of accessing the excess. And yeah, this is the video which I played inside one of the rock object, and which is about putting the 3D scanned rock model into the image generating AI to create multiple of fictional rocks. So you have seemingly like plausible rock, but sometimes you have this kind of a creature-like rocks or mechanical rocks, something like that. So like lots of fictional rocks generated. Again, like generating excess, another excess from excessive data is like is something that I did here. Okay, finally, I will talk about the studio I've been teaching at the University of Tokyo. It's been, I don't know, almost like 3 years since I started teaching with this topic, the theme, Garden of Excess. And this is really about responding to this condition of excess. And in the studio, I ask students to extensively use generative AI in their design process. So it's also an experiment of how the AI can be incorporated into the architecture education or architecture design processes. So I will talk about the whole kind of process or of the semester. So this is the diagram of the whole semester. So first, like, let's see, students are asked to work with image generative AI to create thousands of images, which I called deep down in the obsession. So this exercise, in this exercise, students are asked to generate series of images in like 1 or 2 weeks. And for those like who have worked with image generating AI, you're familiar, but it's about typing in prompts. So basically you type in the text, and based on the text you typed in, the AI will generate images, right? And that's quite interesting. And then actually I asked students not to type in any like architectural kind of words. I I encourage students not to like type in, let's say, like buildings or cities or something like that, but something else. And I encourage students to like really randomly type in those prompts. And this kind of echoes with this experiment by surrealism did. Andre Breton, or all these people who started this movement in art, surrealism, did this experiment called automatism. And it's about writing the sentence without having a specific ideas. And they did this experiment for like hours and hours. And it's really about like kind of going deep into your unconsciousness. So first, like, if you started writing sentences, the sentences like make sense. But like as you go on, you become like more unconscious when you write sentences, and it becomes like really random. And that's where like you immerse your unconsciousness or obsession into the text. And I think like something similar can be done with generative AI. So here is some of the examples of the images the students created. But creating like thousands of images, I expected students to kind of go deep into their obsession and have their obsession emerge, visualized in these generated images. The reason why I'm doing this is that I feel that, as mentioned in the introduction, artificial intelligence can like take over the today's design processes sooner or later. And if that happens, then we need to come up with what as a human can do in the design process, right? Otherwise, whole process will be taken over by the AI, and we will lose a job. So we need to find as a human what can be done and what cannot be done with the AI. And I think that the obsession is one of the key aspects of this. So that's why I'm doing this. But the thing is that the images you generated are basically two-dimensional, whereas architecture is three-dimensional. So you need to jump from the two-dimensional to three-dimensional with materiality. So here comes the next exercise called Hakoniwa therapy. This is based on this psychological experiment called Hakoniwa therapy, or in other words, sand play therapy. It is the mental therapy using this box filled with sand. So the subject is given this box filled with sand, and the subject can put any kinds of object inside the box to create their own world. So again, this is a practice used for visualizing, physicalizing their inner unconsciousness or obsession. So I use this kind of practice to further develop their two-dimensional images they worked in the previous exercise into three-dimensional with materiality, but not with specific scales or specific function or specific site. So it's also they are physical models, but it's not the typical architecture model, scale models. So it's really conceptual models, which we use as a jumping point to develop their final projects. Okay, 2 minutes to go. So here are some of the examples of those exercise, Hakoniwas. And then after that, finally, towards the end of the semester, students develop the final project. So just to kind of quickly show some students' works from the beginning to the end. So this is by Maria. Oh, by the way, we have quite a lot of international students in my studio. I think like more than half of the students are international, and we have only few Japanese students for some reason. So I don't know why, but just to mention. So this is Maria's first exercise. It's quite interesting. I mean, like, like even this point, like, we can see like, her kind of personality also, like, she's using, well, typical, like, back then, like, stable diffusion, like first version of stable diffusion. It's so, like, bizarre. What's this? Is it like a white radish with legs and arms sleeping on this silver bed? I don't know. And based on that, she created this Hakoniwa, or box garden model. And then after that, for the final project, this is already 3 years ago, so this already looks kind of old, but she 3D scanned this model and put into the 3D stable diffusion with the same prompt she used for creating the image, and she got this, and it's like a pavilion piece in a way, and created this drawings, you also like using the stable diffusion. So like even though like all these annotation lines or dimension lines looks kind of plausible, but in reality, like, it doesn't make any sense. And from those like images, she tried to like create a physical objects. So I think like, that's quite interesting. Like, she's not like, content with having everything inside the digital realm, but she tried to like bring that, translate that into the physical realm. And in her case, like, she used this technique of having like stuffed toy and created this actually pretty large. It's like almost like 2 meter large piece. And also, I will show you in the last of the presentation, but we recently did an exhibition, retrospective exhibition of the studio, and she revisited her project and used this 3D model generating AI to create this model. This is another student, Kai, who was interested in this in-paint function in image generating AI, and created this model based inspired by this in-paint function. Like, you have this picture inside picture, kind of nested relationship. And in his case, like, for the final project, he created this game about his project, which is located in this specific island in Japan, and he how can I say, generated all this fictional, factual information about this site using ChatGPT, and based on this information generated by ChatGPT, he created this game, in which you can explore this fictional, quasi-fictional, quasi-factual island and his project. Another student, Nathan, who is interested in this human bodies generated by those AIs. Well, nowadays, I mean, the AI models can generate like perfect, but back then, like, it often generates like 6-fingered hand, or like multiple bodies merged, something like that. But he was interested in this kind of errors, and created this, I can't remember, like a public toilet floating in the sea. This is the project from last year's student. Oops. Oh. Okay. No, it doesn't work. I think. Yeah, well, I will skip. And yeah, this is the last slide. So just like last month, we did this retrospective exhibition of this studio. So it's been almost 3 years. We started this studio with this topic, and we had this retrospective kind of show on the studio. And this is, yeah, quite interesting. We exhibited selected projects from last 3 years inside in the center of Tokyo. So I think, like, oftentimes a design studio doesn't like really look at how the projects can be presented to the public. But since, like, this exhibition was held inside this commercial complex in the center of Harajuku or Tokyo, so like it was a perfect opportunity for us to have our projects exposed to the general public. And oftentimes, like, in architecture education, like every discussion is enclosed within the people who are dealing with this field. But I think, like, it's always nice to have the discussion, like, expanded to the general public. And in that sense, I think, like, this exhibition was a perfect kind of opportunity for us to have that. And yeah, we have like lots of like weird objects, and I think like we already passed, but we cut the Japanese tatami mats and embedded this turntable so that, like, part of the Japanese tatami mat is cut, and the model is like rotating around. All these like crazy details we played. But anyways, that's end of my talk, and I think like I bombarded with like multiple projects with multiple like keywords, but I hope you can have some like takeaways from this talk. All right, thank you. Oh, there's a mic here.
Hello? Yeah, that's fine. Thank you, Toshiki, so much for your valuable insights. I think a lot of what you said raises very important questions and also sort of themes that we discuss here at CEPT itself. Some of it untapped, but I think this is a great starting point also for us to start thinking about some of the things that you said, especially when it comes to these new regimes of making. What you said about aesthetics. So it really brings to the question, what is the aesthetic of the 21st century and the aesthetics of the now? How do we deal with ideas of high resolution, scanning, data, and what is the architecture of it, right? Like you mentioned earlier about modernism and the aesthetic of compression, right, for example. If we take a look at that, well, modernism started to look at architecture as a way of standardization, universalization. There are systems in place, modules in place, and that becomes the aesthetic. The postmodern, of course, rejects parts of it. It's about meaning making, collaging, overlapping signs and things like that. This is not a question, but so much sort of a thought which I had. Often as students, practitioners, we often think of, okay, well, I'm making architecture, I'm making a building, and I have to think of performance as soon as I start designing. I think your projects that you've showed really asks one to sort of postpone that thought, but figure out what is the architecture embedded in some of these techniques, materials, technologies, and a project will emerge from it. I think we often tend to forget that, and we are like running this race to make sense of everything really quick. Especially with a lot of what you showed, we don't know what comes of it really. But it's really important, I think, the way you approach your work, and that's something which all of us can learn from. With that being said, I'm sure there are questions. I'll open it up for everybody, if there are any. Please, this is your chance. Questions? Okay.
Yeah. Hi. I had a question. This is directed towards the studio that you are offering. Based on your experience, would you say that the use of AI in the studio, is it primarily allowing students to imagine something that they couldn't have imagined manually? Or do you think it is allowing them to make multiple iterations, which would have taken too much time if they had done manually? So is it new kinds of imagination, or is it helping you do multiple imaginations, and therefore is it making the task more efficient? Or is it that it is allowing them to do more high fidelity imagination? Where do you think AI is really helping the students in their journey?
Yeah, that's a good question. Yeah, that's a great question. I think like it's both. Students are using AI to come up with something which they cannot come up by themselves. At the same time, yeah, AI allows you to do like multiple iterations so that you have, countless options, which is impossible with, manual processes. But at the same time, I feel that I'm also like skeptical about some arguments that AI can create something totally new, which human cannot think of. I think AI is kind of, in my understanding, like AI is someone like who can work as almost like a counselor. So, students can talk to AI, communicate with AI, and together, they can create something new. So it's not like AI itself is creating something new. And this kind of discussion has been around back in the age of paperless studios. So one of the key figures from that era, Greg Ling, writes in this for this exhibition he curated, looking back into this paperless studio, that he doesn't believe that the technology or digital technology itself invented the new modes of practice, but the idea is already there, but the technology accelerated this development of the idea. So idea itself is already like, invented by the human being, but the technology is the one like who accelerated that. So I think like my understanding and I think like basically my understanding about how the technology, how this digital technology can impact the practice is that way. Yes.
Yeah, I have a comment and a question. My observation is that it's surprising and gives me a sense of deja vu when you use terms like the surrealist mode of sketching and so on. That reminds me of the Austrian architect Koh Immelbloen, who also used to close his eyes and draw his design because he wants to escape what he knew, so that he could produce diving into his deep conscious, which was almost same intent and impact. and also there were many architects who called explicit studio, where you don't anticipate your end product, but you just sort of somehow code the process and let the process take over and so on. So in that sense, I was just wondering whether the needle has really moved or not. You know, we are still talking about going beyond what we know in order to produce something. So even the processes of trying to achieve that is also similar. Only thing I don't know if it's either faster, shorter, etc. Or is the key lies in what you sort of mentioned in passing, which was basically the previous ways were compressed kind of an approach, while this is a non-compressed, so it looks as if you're dealing more with images kind of a thing. So I was not very clear what is the big difference between the processes earlier and the processes now. Second, I think still we are talking in the terms of a promise of a potential, not so much about the promise of the proof of building something. You know, we are only saying that this can deliver this, etc. So our hopes are still pinned on what it can promise than what it has actually built.
Okay. Well, let's first answer to your first question. So yes, I think you're right. Well, what is new about this process is, I think, that's your question, and I feel that there has been a similar or same kind of exploration experiments in the past already, before the before the invention of these technologies we have been utilizing. So again, going back to the previous answer I had, I think the idea is already here, and the technology is really about kind of accelerating this idea. So, well, I mean, although I extensively work with digital technologies, but at the same time, I'm always skeptical about these technologies. I'm not kind of optimistic about the technology. So sometimes if you work with digital technologies, you tend to argue that this is something totally new and this will change the whole world. But I'm not buying into that. I think that the idea itself has been already here, and the technology is really about making it more visible, or making the idea develop, accelerating the idea to be developed faster. So in that sense, I think, yeah, you're right. I think I can, yeah. Well, of course, I mean, as I mentioned in the talk, there's already a similar experiments in the surrealism before the invention of a computer, which I've been doing in the studio. So I think the idea is always already here, and the technology is really about accelerating that. And the second question, I couldn't really fully understand, but could you?
So what we are saying is, for long, whenever something new comes, we say this has potential. So you say, encourage this idea for the potential it actually offers. Mm-hmm. But even in the previous cycles, we have not really seen buildings dramatically change because we have built and shown the proof of that promise. So most of the time we keep hearing at every decade that this is possible, this is potential, etc.
Right.
So we have to invest in this idea only based on the potential, not so much encouraged by what it was actually built.
Right. Right. I think, yeah, I believe that the same kind of discussion happened in 90s, like when Paperless Studio started. Yeah, like, when they, okay, let me see. Where has it gone? Oh yeah, here, oops. Yeah, so like when they first saw this rendering, I mean, like people like questioned that, oh gosh, is this like really architecture? How can this impact the actual real industry? And I think like nobody could like really answer to that question back then. Like a Greg Ling or Jesse Reiser, or there are other like key figures. But like 20 years after, like I think like lots of like ideas emerged from that, started impacting the industry as a computational design or parametric design. So what is interesting about the Paperless Studio is that around that time, of course, I mean, they're not directly related to Paperless Studio, but Zaha Hadid was teaching the studio at Columbia around the same time. And I can clearly see the influence from the Paperless Studio on the Zaha's idea, or Zaha or Patrick Schumacher's idea of parametricism. So maybe, yeah, I would say like, like right now, things happening inside the design studios, especially the speculative ones, seems to be like less impactful to the actual real world. But maybe like 30 years later, that might be like something which can impact the real world. So like we as a people like who are dealing with academia, we need to be like really hopeful. Not like, of course, I mean, like pursuing the direct, immediate impact to the real industry is, of course, really important. But at the same time, like we also need to invest into this kind of a long-term, speculative kind of approach too. That's my, that's my take on. Yeah. Yeah. Oh, yeah.
Thanks for the very nice presentation. Very much enjoying it. Also have a lot overlapping interests, if you know my work as well, right? I think since you're talking about the Paper Studio, I think back then, now is a bit of a different scenario. I mean, I recently wrote an article on the Paper Studio in relation to AI. So apparently back then, Stan Allen, Jesse Reiser, and Greg Lin, they actually had a philosophical a priori, meaning they came in with a particular set of philosophical interests and also a set of philosophically related visual language, of which the digital tool built upon, rather than the other way around. But currently, what's happening now is that it feels like there is a philosophical lack, right? Which meaning now is the other way around, which has to do with the scale of automaticity, right? Which is very different from the automatic writing you're saying, in the sense that in terms of scale, it exceeds the human mind, right? So there is this very strange situation whereby your students actually, unlike the surrealists, they kind of didn't start from scratch in a kind of a pure natural sense, because they've been, if you like, their mind been excessively not contaminated, but informed by what they are seeing. So that automatic writing, there is sort of, if you like, a kind of a meta-automatic process where they've been seeing thousands of Midjourney images, which then, if you like, contaminate the original natural flow. in that sense. So we're in a very interesting situation right now because unlike the previous studio of that time, unlike the surrealist automatic writing of their time, there are many other factors at play. So as you said, we have material access. Now we have almost access of mental imagery. Yeah, so maybe you can.
Yeah, well, yeah, that's super interesting point, and I don't, I cannot come up with the immediate answer. I need to like really digest and think over. But yeah, your point that back then in 90s, yeah, people had an idea prior to the technology, whereas now, yeah, it's totally different. That point is like really interesting, and yeah, you're right. That's true. And how can we deal with that situation is, yeah, you're right. I think like I need to like really think over that. But yeah, I don't really have any, immediate answer, but like, yeah, thank you. Yeah, thank you for that point. Yeah, great.
I just had I don't know whether to call it a question or an observation, but when I see the work that is done in the lab, where these installations are created, and then I saw the work of the students, which also in a way were creating these objects. And there was one very telling image of somebody standing in front of your London design object, the person viewing the object. And to some extent, I felt that it was a metaphorical sense of being distanced as a human being from what is being done. All of the projects showed the human being outside of the project and never as inhabiting the project. Now, I don't know whether it is conscious or it is a philosophical position that you take where AI and the human are distanced.
I think, yeah, that's really interesting point. I think that's partially technological reason. So especially with this kind of generative AI, image generating AI or 3D model generating AI, it's good at creating like exterior images, like, you know, the exterior of the buildings. But when it comes to like interior, of course, the image generating AI is like really getting better and better. But for the 3D like model generating AIs, right now I think like it's almost like impossible to create like interior space, you know? I don't know, I mean, I think like I need to like, you know, kind of leave this question to Emmanuel, but, so I think, yeah, the reason why like the human seems to be like, how can I say, like, separated from the object comes from that, like really purely technological kind of limitation. But at the same time, I am personally like interested in like how can I say, like non-human agency, and like really kind of creating something which human itself doesn't have any access to. Maybe like, you know, that's another reason why you have that observation. Yes, yes.
Thank you very much. Now, I have a two-part question. I don't teach architecture or design, but I kind of, I'm responsible for at some level. So my question is, since this is one studio, in the student's life at your university, where exactly does this studio come in? Does it come in at an early point, and a midpoint, or the end point? And the second part of the question is, what has, now that you've done it for 3-4 years, what has been the student's journey after the project, and how have they then gone on to use it or not use it at, you know?
Right, right. So the studio was set as part of this vertical studio framework. So this is a graduate school studio. So the masters or actually this year one PhD student took the studio. So anyone from the graduate level can take. So some took the studio in their first year. Some took this in second year. And since this is a vertical studio, so we offer like something like 10 studios each semester, including this. And other studios, sometimes like in other studios are about like really pragmatic ones, like really designing the library or, so not, strictly like related to digital technology at all. So students can choose whether they want to like, have something like, a speculative studio or something like really pragmatic studios. And as for the second question, yeah, it's been 3 years, and for some reasons, students who took my studio tend to prolong their student life. So actually, yeah, so they don't want to like graduate in a short sense. But they are actually, well, of course, I mean, they, still like many of them are going to like typical career path, like going to work for general contractors or architects.
Are we slaves to the technologies that have been given to us? Because there are certain technologies that come and they disappear, like the pager disappeared. Virtual reality, augmented reality, they have been around for a while, but suddenly nobody talks about them. And of course, it's possible to take a VR headset and walk through these spaces because they're all digital models. And to get that, so was it a conscious effort, or do you also feel that, being in Tokyo, that there's a sort of correlation between the corporatization of technology versus what design is? Because there is a conscious or a subconscious design effort, and then it's the tools of technology that are available to you at that moment of how you express. So what is available to you and what is not available to you, and thankfully today AI is available. Tomorrow a certain part of it may or may not be. So do you think we're always sort of interconnected with what is available and what is not available in the technological realm?
Yes, I think so. But yeah, so you mentioned about the corporatization.
Yeah, I mean, you had the VR headset that came out. It became very popular 3 years ago. 4 years ago, Meta came out with it. Then
Right.
suddenly they decided not to continue it further. And
Right.
all the projects that dealt with, even construction projects that dealt with VR and AR, were suddenly put on hold. And suddenly you move on to a different technology. You
Right.
move on to 3D printing.
Right.
You move on to something else.
Right.
So is it that we are just leaving these fragments, disconnected fragments, which are not taking a final shape, which actually could, if all of it comes together as a more collaborative process?
Right. Yeah, that's a huge issue today, because especially in this field of AI, everything changes so rapidly, right? Like, if I don't follow like what's happening in the AI industry for a week, then I cannot really catch up anymore. Something like that. It's so drastic. And and at the same time, like, corporatization is like really happening rapidly. So even like looking at this image generating AI, up to last year was quite interesting, because how can I say, like, the AI was not that sophisticated, so it creates like lots of errors, interesting like errors and mistakes, which we can leverage on. But now, I think like many of you have witnessed of this flood of Ghibli images, generated Ghibli images on the internet. But now, like, this emergence of the new model by the GPT-04 image generation, now like it became so, how can I say, sophisticated that there's almost like, seems like there's no room for interesting errors. And I feel that now, like, I'm not confident of doing the same like studio again this year because of this technological advancement. So yeah, that's and yeah, so like the technology can like easily get obsolete and forgotten. That's a huge issue. And so I think like in that sense, we really need to focus on creating the idea rather than like really chasing the technology around. So I think like your point somehow like connects back to like Emmanuel's point that like we are now like facing the lack of philosophy ideas, but now like really need to like think about, come up with a new idea. Otherwise, I mean, we'll just kind of be abused by different emerging technologies and worn out. Yeah, you're right. So thank you for that point. Yeah, I don't know whether we have. Oh, yeah.
Sorry, can I ask one last question?
Oh yeah. Oh, okay.
So I'm, just as a disclaimer, I'm not an architect. So my question is, I mean, I have access to pretty much the same kind of generative AI tools, and I could be one of your future, let's say, pain in the behind customer, who earlier used to come and say, give you a design brief saying, I need X amount of space, Y amount of definitions of whatever it is. But now that I have access to pretty much the same tools
Right.
that your students have,
Right.
how do you think my conversation will be different? And maybe how can you train your architects to deal with a difficult person like me, who now comes and says, I want this impossible form and function, and you probably in your professional opinion think that's either not possible or whatever it is, right? So my question is, how does the dialogue between the end customer and the architect change? And how does the architect as a professional deal with people like me, my future version, when your students go back and set up those practices? Does that make sense?
Yeah. Yeah, that's a really interesting point. Okay, and one example I can think of right now is that in Japan, or I think there should be a similar kind of enterprise anywhere in the world, but there are like lots of services for end users to generate like interior image of the shop or whatever. And you can give that generated image to the architect, and the architect can design actual drawing based on that image the end customer created. And well, I mean, being being a practitioner, that's almost like a nightmare. Like the customers, I mean, like your client is like, the one like who is taking control over the whole design, and you're just working for the client to come up with a technical drawing. And that's something like, we really don't want to have happen. Right. I don't know. I mean, well, as a profession, I think we really need to come up with a way to how can I say maintain our agency as a profession. And I don't know what we can do for that. But I think really the this issue of going deep dive into the obsession is something really I think potential interesting in that sense too. So again, going back to this experiment by surrealism, automatism, some observes that when the experiments go on, in the sentence, you lose words like I or we, and becoming more you lose the singular subject like I, and the sentence becomes more about plural, so we. And some observes that that means as you go deep dive into your obsession, somehow this obsession is something which is shared among the same generation. So what I'm saying is that oftentimes obsession is seen as something really personal, but if you go really deep dive into this obsession becomes something collective. Something I think there's some kind of a collective obsession of this generation. So if we can touch on that, then maybe I think that might be some way of kind of going beyond this issue of architects being just a technical draftsman in a way. I'm not quite sure. I mean, I'm just thinking out loud, so my thought is still not really random, still random. So I don't think I'm giving you a clear answer to that. But yeah, thank you for pointing that out. Yeah.
All right. I think that's time. Thank you so much, Toshiki. We will take a 15-minute break, and then we'll be back for the next session, which is Aditya from Twasta. All right.
pioneer advanced manufacturing techniques in construction sector. Under his leadership, Twasta has developed cutting-edge 3D printing technology to enable faster, safer, and more affordable building processes. Twasta has successfully collaborated with industry leaders like Godrej, Tata Steel, Saint-Gobain, and India Cements, and has executed projects ranging from 3D printing toilets to demo structures and full-scale houses. The company was recognized as the best startup in construction by Construction Industry Development Council in 2018. Twasta has now expanded its wings to US and Middle East markets, intending to be a global player in construction 3D printing domain. Aditya's deep interest in technology and business allows him to bridge the gap between innovation and commercialization. He has been instrumental in developing industrial-scale 3D printers and materials holding multiple patents in his work. Twasta's collaboration extends beyond Indian shores with partnership across US and other countries. With this, I would like to invite Aditya to the dais. So welcome, Aditya, and we are great to have you here.
So thank you so much for inviting me here, and it was great to listen to the talk previously as well. I mean, those are the kind of designs and thought processes that percolate to the architectural field and the design fields over a period of time, and hope it'll inspire a lot more designs in the future. So today, what I will be speaking about is primarily around robotics, automation, and machine learning, and how we utilize this in driving a few changes within the construction sector. We are a company based out of Chennai. We have a base now in Mumbai as well, and we essentially manufacture robotic systems and 3D printers which automate construction processes, entire buildings. So this 3D printing is a movement that has been going on across the world for quite some time. I mean, if you think about it, polymer 3D printers have been there from 1980s. And construction 3D printing in some way started around 2000s, but really took a good shape around 2013, 15, that time frame. And we have been printing larger buildings, I would say, from 2020, around that time frame onwards. And automation in construction is something that people have been trying to do for quite some time, but I would say it's only now that technology, materials, software, and circumstances are coming together to actually make it happen in a larger way. So this is what I will be primarily talking about, and one would be regarding our work in this sector. Certainly I would want to touch upon our experience in working with architects and how I feel architects can prepare for, I mean, certainly, I mean, if automation is 1% of construction, now it is going to be 10% and more in the future. It is not going to come down. So how can architects prepare for this? Integrating BIM, which is happening but taking more prevalence. And also what sustainability and customization can mean for the broader industry moving forward. So this will be what I'll be speaking about. This is a broad timeline of our work. So we started as a 3D printing club within a university. I did my master's thesis in essentially polymer and metal 3D printing. We did some consulting work for some time. We started working on construction 3D printing around 2020. We printed a 3D printed building some time back. And then we have been sort of working around the world in US and UAE on 3D printing as well. We are an 80-member team based out of Chennai, and we have got a few people in Dubai, Abu Dhabi, and US, I mean, managing processes quite soon. So that's a broad perspective about us. I'll just start with a video to show what concrete 3D printing is about. So when people hear 3D printing for the first time, they imagine desktop printers which produce small objects. But concrete 3D printing works at a different scale. Yeah, so this is essentially, concrete 3D printing process in one image. So you have a robotic system or a printer going around depositing a special type of concrete in a layer by layer manner to achieve a larger structure. So the objective here is to print entire buildings, facades, compound walls, infrastructure elements, and we are essentially utilizing robots to make it happen, but of course a new type of concrete as well. So ultimately, at the end of the process, you get a building like a conventional building. You will not be able to feel the difference between normal concrete and this concrete at the end of the day. But when you are printing with it, the concrete behaves very differently. So a normal concrete, you would have seen it flows like a liquid, and it will take the shape of a mold or a formwork that you are pouring it into. But here, essentially, we are printing concrete. Printing is the word. Printing with concrete without a mold or formwork. So that gives you, the architects, much more design freedom than what you would conventionally get. So conventionally, you are either constrained by the shape of a brick or the shape of a formwork that you're using. So if it is a wooden formwork, then you're pretty much limited to straight shapes, prismatic shapes. And if you're dealing with a metal formwork, which is much more prevalent in the West than in India, you can bend it, but of course, it is expensive. It is, not possible to use it once and throw it away. So there are a lot of limitations. Here you can explore forms without any formwork. And you can build layer by layer. So it is called 3D printing because you print one 2D layer at a time. You stack, let's say, 150 layers, one on top of each other to achieve a larger structure. So essentially, these are the key technology elements that go into making construction 3D printing happen. So you have the 3D printer itself, which is the robotic system. You have a proprietary raw material. It is a special type of concrete that we use. You have design for additive manufacturing, where architects really come in, where you, right now people are designing conventional buildings and we are just trying to tinker with them a little bit and 3D printing them. But ideally, what we would like to have are buildings that take advantage of the 3D printing process. You actually can print or build shapes that cannot be done with conventional construction. So that's where architects really come in, design for additive manufacturing. DFAM, as it is called, is very sort of developed now in the manufacturing space. In the manufacturing space for molds and other things where you print with metals, people have been studying DFAM for a very long period of time. The syllabus is developed, the thinking around that is developed. We are just at the very initial stages of DFAM in architecture. And I would say, we have done a lot of work with IIT Madras. Ankita has been, I think, one of our colleagues has been sort of working with CEPT for a while. There is an opportunity for us to actually lead in the field of DFAM because, it's our team in IIT Madras, Ghent University in Netherlands, and one more university in US, which is actually really working at the cutting edge of this. And we have a proprietary software. So right now, the software can take a 3D model that you do with, let's say, Revit or Rhino or any other commercial software. You can export it as an STL input, and the software can take and print with it. And of course, we work on several sustainable solutions regarding materials, so that I'll speak about that. But it's really DFAM and proprietary software that architects should be bothered about right now. So these are various types of 3D printers. So just to give shape to imagination, we can work with different types of systems. So this is what we call a production 3D printer, which works inside a factory environment. So using this, we can produce different shape panels, which you can then assemble into a larger structure. So this is what we call off-site 3D printing or factory-based 3D printing. And I just want you to notice one more thing. So when we 3D print structures, they can be partially hollow. So we can have material exactly only where you require material. So when you practice conventional construction, there is no option for you to sort of make it partially hollow, get very optimized structures. So here you can have very topologically optimized structures. So here the material saving will be upwards of 40%. So this is a robotic arm-based 3D printing system. So here, this system can sort of create and craft much more complex, objects. than a gantry 3D printer, which you just saw previously. I'll show you a few monuments that we have done with this. So this is an on-site 3D printing system. I'll show you a building that we did with this right after this. So just to give you a scale of the printer, you can see a few people sitting at the bottom. Here. So, I mean, the printer is essentially 3 stories tall. So it's actually bigger in sort of dimension than this entire hall. It probably is double the size of this hall, and then 3 stories tall. So you can print an entire building inside it. And this is a robotic arm system that can move at the construction site. So in the previous printer that you just saw, which is a 3-story tall build, I mean, you are limited by the size of the printer. So you can build only a building that fits inside that. But here, the printer can move from site to site and print a structure. But the limitation here is it's limited to a ground story construction at this point in time. We can extend it to maximum G+1, but not beyond that. The other limitation is people have to actually position this very accurately from site to site. So, I mean, the operator has to be much better trained than for the other printer. So we have proprietary materials. So primarily we started with concrete. We are now using a lot more fly ash, GGBS. These are sustainable materials. We are also starting to use soil infused materials. So, I mean, it does not, of course, contain 100% soil. We have like 40% binder, either cement or GGBS or others, and then the remaining being soil. So we can work with those sort of materials. So this is the software that we work with. Here you can upload a 3D model directly. The printer tells you how much time it would take, how much material it would take, and everything, and would completely manage the 3D printing operation for you. So after you design and input your software model into the the 3D model into the software, you don't have to get involved in the printing process. The software takes care of the rest of the process. So here, I mean, based on Grasshopper and Rhino, we are just outputting a file directly and then printing with our software. So, I mean, parametric design really gets a life with 3D printing. It's really suitable for 3D printing. So that's something that we use extensively, and that's something that there is a lot of scope for collaboration there. So that's the printing process. So after the file is uploaded, the printer is just going around and printing this was a bus shelter that we did. I'll show you the images. So these are a few buildings that we have done. So this was a house that we did. Actually, this one is in Gandhinagar here, within the Indian Air Force campus in Gandhinagar. So you can see there are integrated facade walls. So the facades are incorporated into the wall of the building. So these are a couple of airman quarters that we did. So this is a bus shelter that we did for Godrej and Boys. So if you take a cross section in the middle here, so it's actually shaped like a Godrej G. So their brand has been sort of incorporated into the structure itself. And it is folding in 3 dimensions if you think about it at the back. So you have a parabola or so you have a curve in this dimension and also in the other dimension. So there is steel incorporated in this. So just if you have questions on that. So this is a monument that we did. So it's like a twisted helix. So this was done for the 75th anniversary of India Cements. So it represents what in India we call Ananta Shiras, or the head of a snake, and done completely in concrete. So this was done in various modules and then assembled into a large structure. There is steel running inside this. So this was installed, I think, about 3 years back. It has survived several hurricanes and everything. It's about 21 feet tall. The site offices. Yeah, so I think that was a generic video that I wanted you to get a picture of what 3D printing is about. So this is a villa that we just finished in Pune a few months back. Just give you a glimpse. So here in this villa, as you have just seen, I mean, we have used various typologies or various types of elements. We have, I mean, facade elements which are integrated into the walls. We have curved elements, cylindrical elements, folding in multiple dimensions. So this was completely printed on site. It's like a monolithic structure. I'll show you a video of how that was done right next to the slide. So here you can see the interiors of this building as well. So there was no plastering done on the outside wall. So like how brick cut finish is I mean, of course, Sept has a lot of brick cut finish here. We are trying to see if 3D printed layered finish can be an aesthetic element by itself. So we can achieve various types of layering, various shapes with layering with different types of nozzles. So in that particular building, we used a 40 mm nozzle, so you get a particular cylindrical layered finish. You can get a squared finish. You can get a fully plastered finish. You can get, I mean, a knitted finish. You can get any type of finish.
This is one of India's first ground plus one 3D printed villa. Did you print this house?
Yes, we did.
Do you mind giving us a short tour of the house?
Of course, 3D printed villa is made by a 3D printing technology where you have these layers of concrete that is pumped in. If I'm to explain it in a simpler term, nothing simpler than that, it can be like making a jalebi. Now look at this.
Not that simple.
This definitely is not possible with conventional villas that we make. And we look at this part is actually squeezing the waves in. Even some other villa, I want some other design. I just have to make some tweaks in the software of the villa.
And are there errors in the 3D printing process?
Of course, somebody is making a mehndi and there is an error. They can just
Before it dries.
Before it dries and then make it again.
And what would be the shelf life?
Shelf life is equivalent to what normal villas would be like.
Big height.
Yes. So you can see that, you know.
So just wanted you to notice, I mean, here on the outer side, you actually have a fully exposed finish of concrete. On the interiors, we have a fully gypsum plastered wall. So as I said, I mean, you can get any type of texture with this. That's not a limitation. But I mean, since you can get any shape and design, we would really encourage people to explore that rather than getting a fully plastered wall. I mean, it's easy to plaster, but why remove that aesthetic is our question.
So we have retained some of the elements of this construction. So it gives the identity to the villa.
What is the carpet area of this?
Carpet area is around 2,030 square feet. Today in our country, everybody is obsessed with sunroof, whether it be cars or SUVs, so why not bring it in homes as well?
Guys, this is the future 3D printed homes.
Yeah, so just to give you a picture of how that was done, so this was the on-site 3D printer that you saw in the previous video. So the printer was taken to Pune. It was assembled at the site. So the printer can be disassembled into modules. We assembled that at the site. And then the entire villa was printed within it. So, I mean, here you can see, so that's a 3-story. I mean, we can do a maximum of 3 stories. This one was 2 stories. So this was, I think, about 8.5 meters in height. So the entire villa was contained within it, and the printer printed the entire thing. So we actually had a small batching plant at the site to mix the concrete, and all the column, beam elements, everything is incorporated within the structure. So we have structural steel within this. We print with concrete which is infused with fiber. Fiber helps prevent shrinking in concrete, which structural engineers would know is an issue. But our effort in the future is to print with much more fiber and textile reinforcement, so that we can at least move towards reducing steel and at a point completely eliminate steel. Because steel, TMT steel brings in a lot of limitation with respect to the shapes that we can explore. So if we are able to have textile and fiber, and to some degree, maybe, TMT rebar whenever it's absolutely necessary, we can explore far more shapes, and it can be automated to a larger extent than what we can. So right now, we print the concrete, we stop the print, we manually place the reinforcement, and then we continue the print. The next step is to actually move towards pick and place of these rebar using the printer itself. So that's the next step, and then move towards more fiber. And so, I mean, we have been actually printing facade elements and wall elements with UHPC, so ultra high performance concrete, where we can have the concrete itself take a much more tensile role. Yeah, so that's that villa. So I want to take a slightly more broader perspective, since you have at least visualized how we carry out our processes. So what is happening, in my opinion, right now is we are seeing many trends coming together in the construction and architecture arena. There is, of course, the macroscopic trend, especially in Western countries, of labor not being available for construction. And hence, there is a lot more processes being automated. Prefabrication was the first step, but in a field like construction, logistics is everything. So unless you are able to prefabricate and build within a 150 kilometer radius, you have essentially lost the plot. You cannot be transporting materials over long distances. So we have designed our 3D printers to be transported near the site, at the site, and print and move to the next site. And the advantage of 3D printing here is every single building can be customized. So if you are doing prefabrication, let's say with steel or concrete. Steel, you get a lot more flexibility, but especially with concrete, you have molds, and with those molds, you are essentially forced to produce repeatable sort of repeated elements. So if you produce a mold with precast, or if you have a mold with precast, you have to produce 100 of those elements for it to make sense. But with 3D printing, today you could be printing a villa like this. Tomorrow you could be using the same printer to print a bus shelter. Day after it could be a facade. The day after that it could be a, toilet module, whatever it is. So since it is a completely software-led process, all you have to do is provided the 3D model that it has to work with. Rest of the process is taken care of by the printer. So there is no productivity loss in moving from design to design. So suddenly you're not in a, let's say, villa development of 40 villas. You don't have to do the exact same shape for the 40 villas. Of course, it's good to have a larger template and a larger design language, but you can make modifications as per the client needs and what makes sense from an aesthetic perspective. So this advantage of machine plus digital software is enabling you to have much more customization possible. This is made possible, of course, by the first element, which is the advancement in robotics. So robotics has become really cheap. When I at least started my journey with this 10 years back, it was very expensive to buy sensors which could work in good consumer space. But right now, I mean, consumer electronics is the cutting edge right now. So what actually goes into space and everything is consumer electronics. It has become that kind of quality. And it's very accessible. Essentially, the code used to run it is, a lot of it is open source. You can learn much more from the net. So advancement in robotics has been significant, where people like us, startups like us, are able to access cutting edge technology. Second is machine learning, machine vision, and AI. So AI is a very abused tool, or abused word right nowadays. So I won't say that we are doing, work like how others are doing in AI. We are doing at the very, I would say we are working on it, but we are not doing cutting edge work yet. On machine vision and machine learning, certainly we are doing several things. So this machine vision has been there for a very long period of time. So machine vision is essentially you take photographs, and from photographs you get very good quality information. So what we are able to do with machine vision is understand dimensions, understand feedback from the construction site to make 3D printers work. So, again, going a little philosophical, what has been the limitation that has prevented robotics from entering a construction field compared to manufacturing field? So if you look at a car factory right now, almost everything is automated. Whereas if you look at a construction site, nothing is automated, except maybe a mixer or a pump. Nothing else is automated. The thing that has been preventing it is the fact that every project site is different from the previous one. Every building that you do is different from the previous one. So it's not possible to automate something if you don't have uniformity, if you don't have predictability. So what we are trying to do with machine vision and machine learning is make robotics much more nimble and flexible. So if you move to today's site, the machine should be able to understand, okay, this is where the boundaries of the site are. This is where I have to position myself to print this building. This is, okay, maybe the human has set the machine 5 centimeters off. 5 centimeters off could mean the entire building is tilted in another direction. So the machine has to be a lot more forgiving, understanding that it is tilted, and adjust accordingly. So that is what machine vision is actually enabling us to do. Impact of sensors. So, I mean, the cameras and LiDAR scanners are becoming so good and so accessible. I mean, LiDARs used to be 50 lakhs plus a few years back. Now it is 5 lakhs. So that enables us to actually incorporate these in these machines and get valuable input that makes it more flexible. Cloud computing. So we don't do any of this computing on the printer. You can imagine the kind of computing power required to do some of these AI operations. So it's all connected to the net. We use Google Cloud. We are able to process this information real time and make the printer work. And of course, we have worked on integration strategy. We own all the aspects of the technology. So we design and manufacture our own printers. We have our own materials. We have our own software. We have our own structural, I would say processes. So that enables us to sort of not depend on others with respect to any of these technologies. So that is enabling us to move more in terms of automation. And we are right now automating the superstructure construction. So the foundation is conventional in most of our buildings. So of course there are multiple types of foundation. You have rubble foundation, raft foundation, pile. So pile and rubble, we cannot automate with 3D printing. But at least from a precast perspective, we can automate anchor footing kind of foundations and raft foundations. So that is something that we are intending to do in the future. So we can have honeycomb shapes which can take much more load for a structure. So, but right now foundation is conventional. After that, we automate the superstructure. The next step for us is to automate the plastering and painting with the same 3D printer, automate tiling and flooring to some degree. So these are, this involves good level of machine vision based feedback. We are already doing remote operation of machines. So we have got a printer in Pune. Actually, our person sitting in Chennai is remotely operating the printer based on camera-based feedback. So that we are already able to do. Next step is also trying to do AI-enabled autonomous operation. As I mentioned, can the machine position itself on the ground based on images? So that is something that we are doing now. And we are building a printer for 5-story plus buildings. I think I have an image of that printer, I'll show you. And the ultimate idea is the world is moving towards complete digital files of the building. So, I've got a CTO, Kalyan, here. He has worked on this much more. He can maybe answer a few questions on this. But at least earlier in India, the practice was we have a rough sketch of the building. We have a layout. We start construction, and then there is a lot of tinkering going on in the design of the building, in the layout, etc. But at least in the West, the world has come to a place where you make a full digital twin, every single detail, before we go towards construction. So if we have that, so in places like Singapore, a BIM file is absolutely necessary for you to get planning approvals. So if you have a full digital twin, you can feed it to our software, and the printer can essentially carry out construction pretty autonomously. So that is what we want to move to. So that is our dream, what we want to work towards. And hence, architecture is also fundamentally moving towards using these digital tools in a much more deeper manner. So I would say a significant skill that is necessary for working with automation technologies in the future is understanding these tools deeply enough. And these tools come with several modules coming together at the same time. So you have, structural elements that you have to design. So a basic understanding of structural engineering is necessary, I would say, so that you're not limited later at from a structural review. So structural engineers by design and by I would say function are conservative. It would be better if architects understand that at least basic aspects of the structural process before designing the structure, so that you're not pulled back later. So that is necessary, and there are many digital tools available to tell you what is possible and what is not possible. So something that we really want to do with our software is have a simple engine that can tell you during the design process, okay, this is possible with 3D printing, this is not possible with 3D printing. So a yes or no gate. So when you design, you exactly know what the 3D printer can do. So that is something that we are developing. But a basic familiarity is good, and understanding these digital tools are really becoming important for the architect as days go by. Because I think a lot more information can be contained within these digital models than what could be done otherwise. I think we discussed this. These are the key elements of the 3D printing process. And one of the aspects that, Janil was discussing with me is, where do you think, from a 3D printing perspective, architecture could come in? So certainly BIM is a key element, I would say. That is where we get all the information that we need for printing from architects, from a BIM file or a 3D file. And if we have so when, let's say, an architect gives us a file, if you already have information incorporated with respect to where the MEP elements will be, the mechanical, electrical, plumbing elements would be, where you want the column and beams to be, or where you want, let's say, some of the window fittings, tiles, etc. So we can manage the 3D printing process accordingly. So one of the things that we do in India, which is very, crazy, so is we first build the wall, and then the MEP guy comes, he cuts into the wall, he places the plumbing elements, and then you sort of build back the wall and then you plaster it. It's just really, double work and absolutely unnecessary. So if you are able to plan this ahead, we are able to incorporate that into our printing process. We leave spaces during the printing process so that you can integrate the MEP elements. And as you saw, the walls are hollow. So you can actually integrate all the MEP elements within the wall. So this is something that could be easily done. So a basic understanding of how these robots work and what their constraints are in your courses, I think, would be very valuable. And a basic familiarity with machines, materials, and structural engineering is absolutely valuable as well. So I think some of you have tried 3D printing with printers in Bombay, IIT Mumbai, and elsewhere. So there are a lot of things that are possible and a lot of things that are not possible. There are several limitations with a 3D printer at this point in time, what can be printed. So for example, if you are printing a, let's say a tilted element, you can have a 20-degree sort of tilt at this point in time, not beyond that. Or if you want a very curved element, you can actually do it if you print very slow. So you have to understand how much time the material takes to set and plan your print accordingly so that you can print an arch. So a basic intuitive, I'm not saying you have to understand it technically completely. So an intuitive sense of what the machine can print, how the machine prints, how the material sets, how structurally it is standing by itself. So these would be very, very useful. And in my perspective, what 3D printing is doing is removing a middle layer between the architect and the output. So, you can ask we have architects who work within our team. Many of them control the printing process till the end, in the sense they give the input, they know the 3D printer well enough to actually guide the system. They actually can plan each and every element of the print plan. So for them, after they give print, the output is exactly what they imagine it to be. So it's removing that skilled human layer between you and what the output you want to be. So it's giving you a lot of power. It's giving you a lot of power to explore innovative designs. Sustainability being a key sort of path in CEPT, it's enabling you to make much more sustainable buildings. So sustainability comes in 3D printing, I would say, from multiple factors. One is we print with much more sustainable materials. So we try to replace as much cement as we can with, let's say, fly ash, which is a coal waste. We use steel slag, which is a steel industry byproduct. We use soil in some of our materials. So using these kind of materials makes your construction more sustainable. Second is you can have walls which are partially hollow or filled with insulation material. So in India, we use a lot of air conditioning for cooling our buildings. And of course, you have heat transfer with the environment. You can minimize that heat transfer. So what happens now, I don't know how much familiar you are with the Pradhan Mantri Awas Yojana. You are building structures for, essentially people who do not have houses in India. So many of the houses are built with technologies like Maivan, where you get 80 mm, 100 mm, 120 mm walls. And these structures are built in places like Chhattisgarh or Chennai, where the temperature goes up to 45 degrees during the summer. And these houses are like ovens inside and during summers. They heat up really badly. So those are some elements, if you think about during your design process, you can avoid by having these sustainable practices, by having insulated walls and ventilation, which you can design very easily. And as I mentioned, I mean, customization is a very key element with 3D printing. I would say the most important factor that can drive 3D printing's adoption is the fact that you have mass customization. So instead of mass production, you have mass customization. So let's say you produce 10,000 products. Every single product can be different from the previous one, and it doesn't really matter. And of course, you have speed. So that particular villa was done in 4 months, but we can actually do the same villa now in 1 month. So earlier, if you can imagine, that kind of a construction might take 6 months plus or 8 months plus, but you can do it in less than a month. Our theoretical capability is doing about, so let's say you are printing a 3,000 square feet villa, you can print 1 meter a day. So a villa which is 2 floors could be about 9 meters. Theoretically, you can do it in 9 days, but I'm saying practically it'll happen in a month. So that's still an order of magnitude faster than conventional construction. So the architects who have been working with us work very hands-on with our printers, and what we are seeing is, and I've seen, I mean, your workshop, people here are really multidisciplinary in terms of their understanding and knowledge, and that really helps when you're exploring a field like 3D printing. A surface level knowledge in many of these things, machines, materials, and structural engineering really helps you to push the boundaries. And one thing about construction 3D printing is when you ask a question, it might be the case that nobody can answer because nobody has really thought about it. It's a very new field. There is a lot of scope for innovation and fresh thinking. So it might be the case that after 6 months of training on this or working on this, you might start asking questions that nobody has really asked and nobody has really answered. So a basic understanding of materials and structural engineering will help you actually arrive at the answer for the first time. So that is a very key thing. And talking about interface between architects and 3D printing, currently you would work with a software like Rhino or Grasshopper or, Revit. You might produce a digital file and you might transfer it to our software. You might still have to do a little bit of tinkering with our software to make it work. And there is no guidance. I mean, it's a lot of your intuitive knowledge which will drive your design process. You will not have a lot of, you would have to learn from people working around you. Our effort is to make that process as frictionless. So we would want you to focus on design, and we are trying to have a guideline, a guidebook sort of a thing to guide architects, but we are trying to arrive at a simple AI chatbot that can tell you what can be printed and what cannot be printed during the design process. So that is something that we are working on. And the second step is we are trying to make our software handle the entire optimization. So let's say you try to print a cylinder and you want to print a particular arch. At this point in time, you might have to tell the printer what speed it should be printed at, what, let's say, print spacing, what nozzle width the printer should use. Maybe you'll print a couple of times and then fail, and then you will print with the right nozzle height and right printing speed. But what we are trying to do is make the software itself know, okay, yeah, you have given me a design that ideally should be printed with a 60 mm nozzle width. And ideally, you're telling me that I should print with 200 mm, but this would only work with 150 mm per second printing speed. So we are trying to make the software smarter so that architects can focus on design. But it's not there yet. Yeah. So these are the 5 processes that lead to 3D printing. So model design, STL file conversion, which is the software handling it. You have the material printing process. And before the final output of the villa comes out, you have other work, right? So right now, woodwork is completely, it happens exactly like conventional. Tiling, flooring, etc., all that is conventional. So we have got a contractor working with us to make the entire structure happen. So these are a few elements of, these are a few images of our software. So you can see a 3D model is loaded. The software tells you how much material is required, and at a printing speed, how much time it would take to print the model. So this kind of a model might take about, so let's say it's a 1 meter model, it might take 1 hour or 45 minutes approximately. And yeah, so you can simulate the entire printing path before you print, so you know if the nozzle is making any mistake, or so you can simulate that and see. And there is a manual control option available for the printer, that is the left hand side bottom. So if necessary, you can move the printer yourself, but I mean, you don't have to do that really. There's a quick video to show you a simple module being printed. So, I mean, if you see here, that's a cube being printed, and as you can see, the print path is clearly shown. So that's where the, okay, it's not very visible on the screen, I think, but I mean, that's the printer moving layer by layer, and each layer you can see it crisscrossing to achieve that particular cube. So you can simulate that entire run and see if, I mean, so before you, let's say, place reinforcements, etc., you might have to just see where the reinforcement members have to be placed, etc. Yeah. So there are several types of 3D printers that we are working on. I'll just show you a quick glimpse of the various 3D printers that we have. I think you saw a few of them in the previous videos. So this is the on-site gantry, of course, that we discussed. So here the entire building would be incorporated within, but we are, I mean, there is a size limitation. You can't have a very, very large printer, right? So we will probably limit ourselves with a 4-story printer, G+3, that can print, let's say, a land square by 15 meters by 14 meters or 16 meters would be the maximum that we would go to. On the length side, you can go as much as you want. On the height, maybe about 20 meters, not beyond that. So that would be the maximum dimension of a gantry. So this is the crawler that we discussed. So this is a small printer that we use for our research and development work. This is the production printer that we talked about. So this is a very interesting system. So we are trying to move towards this and away from a gantry. So this is exactly like a tower crane. So you can theoretically increase the height to 30 stories, 40 stories, whatever it is. It's a much more difficult system to manage. So you actually have an arm that comes out of the tower crane and manages the printing process. Exactly like a tower crane. But the difference is, in a tower crane, you are working with what is called a hydraulic system. So there, even if you get it off by a few millimeters, there are people to position it. You are essentially delivering a module. So the accuracy of modern day tower cranes is like not really great. You're off by a few centimeters, you slowly position it. But when we are dealing with a 3D printer, we need it to be extremely precise. So you're depositing concrete layer by layer, you require millimeter level precision. So we are forced to re-engineer the tower crane completely from scratch. So that is something that we have done. I think I've got an image of a prototype printer that we have here. Sorry. Yeah, so I mean, just quickly showing you images. This is a production printer. This is a stationary robotic arm. And this is the on-site printer. And these are robotic arm on rails, which we use for factory-based production. This is a printer on crawler that can move from side to side. So just giving you a picture of what it can print. So this is like a pillar where you actually have a hexagonal pattern that is embedded into it. So the printer did the entire thing. So you can have these kind of patterns that are there in the wall elements itself. So earlier, if you want a facade wall, you would do a normal wall and then attach a facade element to it. But now you're able to have integrated facade walls that have these patterns embedded within them. And of course, you can do standalone facades. This is the tower crane printer that we spoke about. Yeah, so I'll speak about the challenges, then I'll show you a few buildings and the potential. So the initial cost of 3D printing as a process was high. We have been working on it for the past 5 years. The cost of buildings was a little higher. We are able to bring it down significantly. Our material cost, because of some developments that we have done, has come down by nearly 40% over the last 1.5 years. So it'll come down further. We are trying to make it equal to precast and equal to conventional construction. So that is the effort that we have. So if we have a few number of buildings at a site, we are now matching these costs. Market acceptance was an issue earlier, but now people are understanding that essentially we are delivering concrete buildings which are very similar to conventional construction. We can offer better life. We got regulatory approval from Ministry of Housing, so that has been a big boost for us. And of course, people are seeing future potential for design. So, but the potential was in the future, so that was a challenge for us initially. So just showing you a few images of buildings that we have done. This is a 3D printed house. I think we saw this in the video. This is a structure that we did in Gandhinagar. So this was done in 30 days. These are a few bus shelters that we have done in Mumbai. Now we are doing about 80 of these in Chennai. So especially in coastal areas, I mean, steel bus stands rust really quickly. So people are preferring concrete bus shelters which can have 30, 40 years kind of lifetime. And of course, as long as they're aesthetically designed, it's better. So these are a few site offices. So this was like a site office that we did for Godrej Construction, for a construction site that they have. So here the difference is that this was done with volumetric modules. So in normal precast, you might have 2D panels that you assemble into a larger structure, but this was a 3D volumetric module. I'll just walk you through a quick video of this.
Imagine a world where innovation meets a greener future. Presenting Cocoon, a blend of modern engineering and environmental stewardship, brought to you by Godrej Construction. The Cocoon, a 500 square feet office, was installed and made fully functional with an impressive 40-hour time frame.
Sorry.
Environmental stewardship, brought to you by Godrej, functional with an impressive.
So just pausing here. So you can see these are 3D volumetric modules that was printed one at a time. It was printed in the other dimension and then tilted, vertically. The site work was actually 40 hours. So the time we started the foundation from foundation and the end, that is like everything including door, window fittings, everything was 40 hours. But of course the factory work was a couple of weeks before that. So we did a lot of the work in the factory. So everything including the foundation and the roof, everything was done with 3D printing.
Cocoon embodies the seamless integration of advanced engineering techniques with modular construction principles. Its design.
And you can see that the modules, if you do this with precast, you would have a continuous cylindrical or a cut cylinder kind of a shape. But here it sort of bends. So every module was different. So with the same 3D printer, we produced, I think, about 8 these modules. Each one of them was slightly different in shape.
Characterized by its namesake, is an organic continuum where walls and ceilings merge seamlessly, showcasing the potential of 3D-CP technology with its unconventional curvilinear elliptical design. Cocoon offers a maximum usable office space of 500 square feet, featuring a column-free layout and prefabricated toilet units, all integrated with MEP services to optimize efficiency by applying lean construction principles and utilizing tools like business information modeling. The construction process was meticulously planned and streamlined, ensuring maximum efficiency and cost effectiveness. But Cocoon isn't just about speed and efficiency, it's also about sustainability. From its use of recycled concrete aggregates sourced from construction debris, to its progressive solar tree structure that generates solar energy using photovoltaic panels, every aspect of Cocoon embodies environmental stewardship, making it an off-grid structure. Surroundings of Cocoon are also...
So that is on the outskirts of Mumbai. So this is another security cabin. So that was done with 3D panels. This security cabin was done with 2D panels. So that's a small structure. So this was the monument that I spoke to you about. So it's a twisted helical concrete element. This was another, summer house sort of a structure that we did in Kerala. So you can see the facade pattern that we achieved here. It's like, since it's Kerala, we tried to achieve the texture of coconut leaves, which are sort of coming together on the outer part of the building. So a facade pattern of that sort. And this is a building that we are just completing, sorry. This is a building that we are just completing in Chennai. This is a guest house, so it's a 3-story kind of a structure. It's shaped like a termite mound. So it's like a termite hill. So it's folded in multiple dimensions. It's completely done with panelized construction, so it is not on-site. So you have panels like these which are assembled one by one into a larger structure. And the mandate given to us was, it's a very beautiful site inside the IIT Madras campus. So you have a lot of trees. Not a single tree had to be cut. So we had to design the entire building around the trees. So you have got a tree coming right in the center of the building. And you can see, this has about 600 panels which come together to have the entire structure. Every single one of the 600 panels is different from the previous one. So every panel was unique. So we had to print each one of them, in a very slightly different format and then erect it into a larger structure. Yeah, this was the villa that you just saw. So these are several facade elements and landscaping units that we have done with 3D printing. So the combinations that you can achieve with this in terms of design is essentially infinite. You can achieve any pattern you want, any design you want. And you can, a question that I often get is, can I get rid of the layers? You can if you want to get rid of the layers. We can print with square nozzle, which can completely remove the layers. One more effort that we are taking now is, so this is, the concrete 3D printer depositing these layers. So we are trying to have a small subtractive tool, like how you have a CNC cutter to cut wood. So we would have a small subtractive tool that would sort of shave off some of these concrete layers when the concrete is in its green state or when it is a little more pliable. So we would remove those layers so that you can sort of get very smooth finishes. That would enable you to explore far many more designs than what you would be able to do right now. So we have not completely integrated that. We are in early stages. So one of the things that we are doing with this is doing a lot of jali, facades, these kind of elements. We are trying to print with a lot more fiber incorporated and textile incorporated materials with this. So one of the advantages with facades is, people go for concrete facades now. It's really a trend. Concrete precast facades are very, very heavy. So sometimes when you have a 50-story building and you have facade elements across the building, on the 50th story, you are forced to take a 400-kilogram panel and assemble. So it's very expensive, very inefficient. So usually those panels might be about 150 mm in thickness. So with textile reinforcement and with fibrous reinforcement, we are able to make these panels 50 mm or 60 mm thick. So in terms of cubic meter of concrete is usually 1/3. So what would be a 500-kilogram facade panel will suddenly become a 150-kilogram panel, which you can easily lift. So a lot of material saving is possible with this. And that's a key aspect of our work. And so one thing that we say with 3D printing, we are trying to save you architects from engineers like us. We are trying to make you much more liberated and less dependent on people like us and less limitations as much as possible. So, I would say 3D printing is really a tool for architects in that sense. It's up to architects to take maximum use of this. And from what I've seen, the only people who apply real thinking to a building process is, of course, the structural engineer and an architect. There's usually a lot of squabble, but we are trying to limit that. We are trying to give architects as much liberty as possible. And a little bit of understanding of constraints would go a long way in sort of making 3D printing viable for this large-scale construction. So thank you so much for taking the time to listen to me. Happy to take any questions.
Thank you.
And it sort of compels to think. So as an architecture explores the new frontiers with shifts and advancement in digital technology, we see an exponential change in the way we access design, construction, and respond to people's need. In the case of India, and particularly architecture, our connection to industry now needs to be more smoother than ever before, as demonstrated by you. We remain at a juncture where innovation and industry collaboration will be key to accessing technology in an age where India will have to jump to resource restraint while learning from excesses of resource, which are case studies in different parts of the world. Your presentation touches upon the delicate strands of shifts in construction technology to concrete, 3D printing, automations, its infrastructure, integrating automation technology with sensitive resource use, and embedding advancement in digital know-how for manufacturing in a potentially transformative manner. Apart from fully printing buildings without molds and formwork, these advancements may significantly impact construction, including, and I have interpreted, jigs, formwork, mobility, components, construction time, and type of resource use. So the offset of all of these are some of the other things. Most fundamental, however, is the ease with which complex geometry can be worked out in the future, which was time consuming and resource intensive with analog methods. You have already showed this in some of the work that is there. We may also see a surge in complex form with future improvement in material and printing technology, which all of you are doing. Of course, it always raises the question about what do we do. It was also in the earlier presentation as well. So when used in an informed way, these technology will further the ability of human hands and minds to achieve more with less treasury. Now, it depends on how technologies are used that it can be advantage or disadvantage. Your presentation also recalled me the book by Alec Ross, In the Industries of the Future, where he argues the inevitable shift in the growth from a low-cost labor to innovation in technology like robotics, 3D printers, nanotechnologies, and other things. The shifts are also slowly and steadily towards the genetic code, perhaps the beginning of the last frontier of process of life, where machine could imitate humans. Future industries will be built on data and automation, which we are witnessing and using anyway, and it's still a work in progress before it fully synchronizes with human life and production. The earlier presenter also talked about Mario Carpo in the book, The Second Digital Turn, Design Beyond Intelligence. The book starts by saying architects tend to be late in embracing technological change. However, if we really think about it, architects use mature technology to work with fellow engineers, agencies, and artisans to address questions of space and gravity. They wait for the simulation to be more precise, the analysis to be more accurate, and the behavior of simulated forms to be generously predictable. In all these, we need to deal with the emerging uncanny valley, which I think comes with all kinds of technologies whenever it emerges. I can say it is equivalent to calibrating a machine with a least count. In architecture education, if we have to pick up, and I have brought some of the points here, is that yes, BIM, mass customizations are important. Familiarization to machines are important, as you pointed out. But also now, for the first time, it is much more possible to see in a much more nuanced way the 3D stuff. Right. So rapid prototyping becomes very important. So we were too much dependent earlier on physical models as well as on paper. Now we have far more evolved technologies to look at 3D. Complex geometrical printing would be far more possible.
and as per Indian standard for practice, not more than 40% you can replace. Right? So everybody is doing that. So in carbon footprint, you are no different. Can you just tell me what's the average thickness of concrete in your building?
So it would be about, I mean, if you're rebuilding a wall, it would be
No,
approximately.
wall and floor and everything.
Yeah, so it would be about 80 to 80 mm or slightly.
Exactly, but that's where the difference is. If I do a structure in frame, it will be almost 35%, half of. So you are using more concrete. So comparatively, when you're using double the concrete, carbon emission is obviously more. And in your concrete, what happens is, it is because of layers.
Right.
What happens is the strength will not be same as normal concrete. It's almost 60% of that, 40% reduction. So you are using more cement to get the more strength. You are using other chemical. So this whole thing about carbon emission and carbon footprint, it's fine, it looks good here. But otherwise, in number of, you should put, I think, right now, you know that one of the challenges is that how do you reduce this, carbon emission. So in that case, this whole technology of 3D printing, if you are doing a 10-story building with 80 centimeter average thickness, that's too much for everything, even for foundation. So let's not do it. Let me put it this way.
Yeah, so I'm talking about not 80 centimeters of wall thickness, that is.
No. 80 centimeter on the square feet.
Usually a wall would be approximately about, if you are not doing my one, it would be approximately 150 mm that you might do with a double layered brick. Yeah, so we are.
No, but I'm not talking about that also. I'm talking. Okay, I'm coming to the next thing.
Right.
Is that if is there a possibility that you can have the certain elements, printed into this, and certain elements or some enclosure is done with some other material?
Certainly. I mean, it is ultimately concrete, so you can join it with brick and mortar structures or even pure concrete frame structures very easily. So that is not a challenge. Yeah.
That's fine. Thank you.
Hi. Hi, here. Hi. I have two questions. One is, have you done any project where the dense trees are there and say suppose a hill where forests are, where the regular construction technologies are not accessible or difficult to bring in material for that matter, right? You're reducing number of material being used, at least for the walls for now, right? And later you're saying that if you build with domes or walls or something like that, it will even reduce for the horizontal spanning elements. So that is one. And second, in terms of energy, now it is mechanized and it needs a power. So what is the power consumption which it needs? And suppose, again, I'm going back to the locations, what I'm mentioning again, forests and hills and all that. There are
kind of systems where we are having layered kind of construction, you know that the main problem is with the compressive structures are okay with this kind of. So you're doing in this kind of way. So I understand for the vertical elements, you are putting the reinforcements. I didn't get any visualization about how you are putting reinforcement while you are printing the slabs, horizontal elements.
Right. So, I mean, if we are printing for those bus shelter kind of components, those are printed in one direction.
That I can
and printed-
visualize.
Yeah.
The slabs in the villas you showed.
Yeah.
How are you printing those slabs?
So for smaller span slabs, we can actually print in the vertical direction, place reinforcement, and then we can tilt. In the villa components, the slabs were precast at the site.
Not printed.
Yeah.
So I was not able to visualize
Right,
that. Second question, very small question. What is the water usage ratio? What is the same? And curing?
Right now we say about 3 days of curing is good enough, but we are trying to move to air-based curing or chemical-based curing.
Okay. Thank you.
So, okay, thank you. So we are already doing, so as a part of the Masters in Computational Design and Fabrication program, our SEM4 students are already collaborating with Twasta. So we've designed the entire studio in such a way where the students first learn the softwares. They understand like what all the things he was talking about, the designs, what we can explore. The machine. So it becomes an integrated and an incorporated process where, and like Sankalpa was suggesting rapid prototyping. So we also simultaneously prototype to understand how the whole system and the whole works together. So the students, as a part of their final studio project, they have already designed a couple of structures, and in all honesty, very happy to tell you that day after tomorrow, they're going to go to Twasta and build these complex geometries. So again, like he said, emphasized a lot in his presentation that architects are the ones who can push boundaries. So that is what we are trying to do. Start incorporating some of the questions with Mangesh also asked. Start looking at shell structures. So you start printing at angles. Without reinforcement, with reinforcement is something that they will be experimenting as a part of this entire journey. So, and yes, we are in the process of also structuring more courses around this so that it actually becomes an integrated skill within an architect's journey of learning. Either they are doing BArch or later on when they are doing masters.
Thank
So,
you.
If you want to add something to this.
And as a practicing architect, what would be the, so I had a similar question which Mangesh asked, you know, how do you construct slabs and lintels, and any other things that you can say right now about integration of MEPAF or waterproofing of slab, which are, you know,
Okay. Hi, good afternoon, everybody. Welcome back again. So now we have a session by Emmanuel Ko. Emmanuel Ko is an assistant professor in design and artificial intelligence and architecture and sustainable design at Singapore University of Technology and Design, SUTD, where he also directs artificial architecture. Trained at the AA in London and holds a PhD from School of Computer Sciences and Institute of Architecture at EPFL. He is an international pioneer in AI and architecture and a principal investigator for several AI research projects, such as those supported by AI Singapore, Design Singapore, Urban Redevelopment Authority, Ministry of Defense, and National Arts Council. Internationally, he conducts AI research for high-profile architecture practices such as Zaha Hadid in London, MBRDV Rotterdam. His work has been featured at premium AI conferences, awarded with prestigious architecture prizes, and exhibited at international museums. Emmanuel is the author of book Artificial and Architectural Intelligence in Design and guest editor of the IGAC special issue Artificial Architecture. Accelerated 3D forms with generative artificial intelligence. He is also the conference chair of CAGIA 2024 and co-curator of the Singapore Pavilion at the Venice Architecture Biennale 2025. With this, it gives me immense pleasure to invite Emmanuel to the dais. Thank you, Emmanuel, so much.
Hi, thanks for the nice introduction. Very happy to be here. This is my second time. The first time was 2023. Yeah, so I like the city. Very architecturally interesting. So today I'm going to talk about, I'm told that I should talk a bit more on the pedagogical side of things also. So I would also talk about those things in addition to the research work, and also providing you a kind of a theoretical framework, which I call it neurotectonics. Neuro meaning from from deep neural networks. That's why the word neuro. Tectonics is something that we're all very familiar with. So basically, in my research lab, I do a number of things across different spatial scale, as mentioned just now. That I work with industry, project funding, also from the government, but also publish in both domain, the AI conferences, but also architectural design context. So there are many projects ongoing. Some actually have ended just last month. And so across different projects type, I got to learn how the same technology could be transferable from defense to art, from art to architecture, for instance. For those who are interested in reading the easier reading beyond, conference journals and all that, these are some of those that I have contributed as chapters or featured in the book. The forthcoming one, quite a few for this year. Two of them will be out soon. Guest editor is Philip Yen from Tongji University, who is the co-founder of Digital Future. So there will be a special issue where I wrote about neurotectonics, both in English and then they translated in Chinese for another magazine. So today's talk, I will draw from a few of these writings, including one from the second edition of AI and Architecture by Stanislaw Shiloh, who, if you recall, he was the one who wrote Archigan back maybe 4 years ago. So he's releasing a second edition, so I'm contributing again to the second edition and really looking at the 3D encoding, which I'll talk about today. So I also mentioned just now to Toshiki that I wrote an article on Paperless Studio and its relation with AI. So that one should be out. And then we have a clicker here.
should be over here with the Zurich University about what does it mean to have a post-paperless studio. That one is actually very interesting. I want to talk to Toshiki sometime because when they say paperless studio, in fact, they were still using paper. So it's not true. It's basically a kind of a way to more like a reactionary framing. But anyway, that would be a separate conversation. So as I mentioned, I teach in both programs. I thought it would be nice to kind of show you the curriculum very quickly before I go into the theory part and also the projects. So in SUTD, we also have a foundation year. I just learned from Gina that you have a foundation year where everyone learns the same thing, kind of, and then they branch off to their own major. So we have something similar, so I'm not showing that. That it will be term 1, term 2, term 3 this year. So in architecture, I mainly, and in the design AI program, I'm mainly teaching the creative machine learning course and another theory course on AI and intelligent architecture. So things like Cedric Price, Nicholas Negroponte, the students are all exposed to the sort of history where we came from in architecture in terms of intelligence, but also teaching other courses, especially also supervising thesis students, mainly on AI and architecture. And then a spatial design studio, which briefly shared over lunch with some of the SEP colleagues. This is a very unique program, started in 2020, and then first cohort student graduated last year in May. It is the world's first Bachelor of Science in Design AI program. And also recently, SUTD, which is Singapore University of Technology and Design, it has recently rebranded itself as the world's first design AI university. Essentially, there is a sort of a dramatic reframing of the whole pedagogy within the university in a good way. So just to show that the AI hype that we are currently witnessing has an almost immediate impact on how courses been developed and kind of added. So when I first joined SUTD, I was asked to create a first AI course for architects. And then very quickly, right, we've got suddenly that elective became a core. Suddenly the history course also is a core as well, but instead of looking at modern architecture or vernacular architecture, we look at intelligent architecture, unbuilt or built, many unbuilt, right? So this is sort of a progression, right? I don't know what's going to happen in 2026. There are many new master programs, but let's see how things unfold. But bear in mind, I'm in a very unusual context in Singapore, where there is a huge drive at the national level. Therefore, they set up the AI Singapore. And there are lots of, these sort of strategies. If you're familiar with Singapore, it is a country whose government is very strategic about stuff. And once they decided, they invest a lot. And fortunately enough, I'm in that space where I get funding for my AI research, even though traditionally architecture research is usually quite underfunded. And at a global scale, we should also be aware that things are also moving rapidly. So if you're curious about, every year, what's the take-home message for the next year, is to read some of these from HAI, from Stanford. I will talk about some of them, but essentially, I'll talk about two of them. First, right, which is the AI performance on demanding benchmarks. They continue to improve very quickly, very, very quickly. And then the last point, which is about complex reasoning. What does it mean for architecture to reason architecturally, spatially? Yep. So what's neurotectonics? I'm sure everyone is familiar with, so I'm trying to use this as a way to frame our discussion. What was pre-digital, what was digital, and what was post-digital. And in this case, Max Prensky he wrote much about, back then, I think 2001, about this divide, a generational divide between those who were born in the digital age and those migrated into the digital age. So if we frame that from a tectonic way of thinking, might there be an analog native tectonic? Might there be a digital native tectonic? And therefore, might there be an AI native tectonics with its own way of doing things, with its own aesthetics? So going back to analog native tectonics, we are all very familiar with Gottfried Sample, right, who talk about tectonics back in 19th century, which is a sort of clarification of lightweight versus the stereoatomics of heavyweight earthwork. And then with the Heinrich Welflin, who spoke about the difference between atectonic and tectonic, and plus the importance of tectonic to architecture, in fact, fundamental to architecture. And then we have Edward Sackler, who talk about the relationship between structure and construction, between form and force. And obviously, the most famous one, Kenneth Frampton, wrote about the poetics of construction, that somehow grant architecture sort of a meaning, which on hindsight is rather sentimental. Because, for instance, he was in the time where it was the post-mod kind of era where there's this loss of meaning, there's this loss of authenticity. So it was actually quite reactionary to sort of salvage architecture as a discipline. And we have the digital native tectonics from Newlich early on in 2000, and then you have the novel tectonics for Jesse Reiser Yamamoto, which takes on a very materialistic approach where there is creative agency from material themselves. Therefore, he spoke about the intensive and the extensive. And Hofstad, Luca Hofstad in ETH Zurich, talk about it as a literacy. And more recently, Tektonism from Schumacher, and then also Catherine Schroitz, who talked about the potential of tectonic in climate change in addressing urgent problems in the world. But on hindsight, there was this issue called tectonic unbound, and there was a criticism about Kenneth Frampton's notion of the authentic, in contrast with the artificial. So here I use it as a springboard to talk about a different kind of tectonic, an AI tectonic, an artificial tectonic. So in that sense, we're concerned with the inherent artificiality of these tools. What is it that in these deep neural networks that one could perhaps allow a certain new language or paradigm to evolve? So in the article that I wrote, which will publish shortly in a month or two or so, the difference is that we're not concerned with a particular style or different styles, simulated styles, but the style of simulating, which is the ways in which the AI model simulate any style. So if we are romantic about this, you can think that you should sort of forsake the fact that there is sort of an AI aesthetic, because there might not be in a kind of stylistic way of thinking about aesthetics, since it could simulate any style. In other words, there might be a native algorithmic logic that underpins deep neural networks, by the way, in the ways in which they learn and generate. And so the task then might be to look for the traces of this artificial and observable neural artifact. So to very diagrammatically clarify, on the left side you have the architecture tectonics, which concerns the material and the assemblage, and then you have the artificial tectonics, which is essentially the assemblage of the unreal material. And on the one hand, you have the traces of architecturality, which is the construction, the poetics of construction, structure, form. But in this case, it's the traces of the artificiality. Of course, these traces, in fact, evolve, because every year, every week, every month, you have a new AI model that comes up, and it has its own eccentricity. So to talk about neurotectonics, we have to look at neural artifacts. Because artifacts are the traces where we could find the artificial, which is the expression of neurotectonics. So for tectonics, it is the traces of authenticity in a way in which Phantom talk about, which is embodied in physical structures and semantics of material culture. Here in neurotectonics, we talk about the traces of artificiality embedded within the structure of deep neural networks and the semantics of training data sets. Essentially, we need to know the architecture of the deep neural networks, the training, the semantics of the training set with which they learned to generate stuff. Very quickly, just to make sure I don't run out of time. The word artifact is particularly interesting. Of course, if you take the American version, it would be closer to artificial. If you take the British version, it would be, with letter E rather than letter I. But in any case, artifacts is understood as something made by a human of great historical, cultural significance, or in science and statistics, it is an unintended consequence. It's a trace, a glitch, if you like, in a way, to some extent, visualized or made apparent in computing and AI research. In this picture on the right, for instance, one is a deconvoluted image showing the pixels and the tendency of certain models to generate certain glitches. So these are what I was talking about, in a way, the traces. And so, just to reiterate, there is this notion of shallow artificiality, meaning AI being conceptualized as a tectonic machine for the simulation of outputs of any style. So if you just use Midjourney straight off and then you generate some stuff, that's in a way shallow artificiality. Then deep artificiality is then where AI is being conceptualized as a tectonic machine with its own styles of simulation process, its own style of simulating any style. So what then are the tasks ahead of architecture to become AI native? What does it mean, or what can we do? Perhaps is to first look at how AI models learn, perceive, and generate in the style of AI. So I sort of try to break it into three parts. First, and then illustrate it with many projects, which come after this slide. First is explicit representation learning, which is a question of encoding and decoding. So to clarify, it basically says how do you explicitly represent architecture data or knowledge numerically. So you could represent, let's say, a floor plan with a graph. You could represent a 3D form with voxels. You could show their relationship with graph neural networks or recurrent neural networks. But essentially, in order to encode it, you actually need to know what the model is capable of ingesting. And then next is the implicit perception prediction. So it's the understanding of how these models actually perceive stuff. Every time you ask an image to text model, you are essentially asking it what it's looking at, in a way. And likewise, from a human perspective, some of the projects that I will show will also talk about how we learn as humans by looking at brainwave patterns and also eye tracking gaze map, and train AI models to create a proxy of us. And then lastly, the complicit form generation, which is an act of reasoning or unreasoning. The topic reasoning is extremely interesting to me because what we designer consider as reasoning may be completely unreasonable for the mathematician or for the engineer, such as analogical reasoning, right? Such as, but let's look at the first one, which is a question of encoding and decoding. Back in 1960s, Liner wrote much about the architecture of form, and he tried to represent, in this case, the Seagram building as voxels in today's language. And then he encoded explicitly as a hexadecimal representation in order to sort of compress architecture explicitly with numbers. Of course, if you look at Villa-Savoye, you can theoretically actually encode the reservoir as a graph. Imagine every column is a node of a graph. Imagine every wall between two columns is an edge. And you can actually encode it that way. And then you train a model, an encoder-decoder neural network model, where you could then either reconstruct or you can then generate. Because you have already learned the latent space, which is a kind of a compressed representation of what is learning. And since you have the compressed way of the training set, you could actually generate new ones. So this is an old project, but it's still very relevant, which is the Air Sampling Singapore project. And it won about 5 or 6 awards, even though it's a digital project. So this project mainly try to see if we could in fact encode the interior and exterior of a building at scale, meaning we're not limited by the voxel size and the number of voxels. Obviously, in this case, if you want to do every single thing as a voxel, you get like thousands by thousands by thousands of resolution. So in this case, you train back then a general adversarial network, which is a particular very popular generative AI model, predates diffusion model, and it learns 3D form. So as I mentioned, we need to know the semantic of a training. So in this case, the model has a 3D massing. It has the floor plans of the entire floor, each floor, and it learns the relationship, and it generates it directly in 3D. And therefore, these are generated on the fly, and you actually cut sections. They are not generated as themselves, just cut whatever section that you have. And here is showing the curation of a data set. So it's called AI Singapore, Sampling Singapore because it's sampling the whole Singapore, all the public housing. As in all good data science work, you need to do your EDA, which is exploratory data analysis. It's to make sure that your training set has a good diversity, and therefore and therefore able to generalize better, and therefore being more generative. So these are actually the data set, actual housing blocks, HDB, and with a geolocation at the bottom. So this is sort of the training set, but back then was not looking at the exterior, mainly looking at the massing, the interior. And as I mentioned, to solve the problem of resolution is to have an embedded parametric model within the generic 3D GAN model. And the project was then subsequently exhibited in an art context. Yeah, just show some images. Because it's trained in 3D, it could generate in 3D, and therefore we could 3D print them simply at different scale. Because in this model, there are 2 separate levels of representation at the massing and then also within the interior. So a voxel is more than just a 0 and 1. In this project, a voxel has a semantic value, a voxel has a spatial configuration as well. And other projects, for those who are interested in the technical part, there are 2 papers that I co-authored with my visiting PhD student from Aalto, and also another one based in London. So building GNN, essentially trying to say, if you could do ChatGPT where you predict the next token, can you or do image in-painting or out-painting where given the mask you could generate whatever. So here, the building GNN is essentially trying to do auto-completion in 3D with a semantic value. So if I give you an apartment unit, what might be the likelihood of a corridor? And if you are at the end of a corridor, what's the likelihood of a stair call and a lift call? We can actually learn that probability distribution. And in this particular paper, looking at using graph neural network to explicitly represent the architecture, using recurrent neural networks, which is a kind of model that learns sequence to sequence, in order to then generate this. And then the next one is, you can have a look. This one is closer to trying to basically use the BIM representation and then use that to compress, re-represent a BIM model. So imagine a BIM model file now is represented by an AI model. of the building. In this case, is the SUTD building, and then you train a model that could actually generate a new building. So it's essentially from building to graph and back to building, using the analogy of image to text, text to image. And in this case, it could generate reconstruct. Of course, in this case, we measure similarity based on, which is the performance of the model, based on the graph similarity, not the form, because infinite number of possible geometric representation. And therefore, we have a different way of measuring similarity beyond the standard ones, such as intersection over union method in computer science. A project that slowed down tremendously because of some non-disclosure issue was the one with Zaha, the architects, where back then trying to not just construct from their archives 3D models. So this was 2023, where image to 3D and text to 3D were quite rare. And one of the earlier tasks was to create a taxonomy for the practice. So essentially, in order to do a taxonomy, you could either ask Patrick Schumacher directly, which I tried to ask, and he couldn't return me the taxonomy immediately because he's the most busy person in the world. And therefore, we decided to say, okay, let's just look at all the buildings with their text and images, and let's expand that material, and then do some data analysis to generate the taxonomy bottom up. So what happens is this. For instance, the first one that you see is, so instead of saying, given an image, give me a text, we do this crazy stuff. Because every text can also be represented with many texts. Every image can be represented by text or many images. So there's this whole convoluted process of expanding information from, in this case, we were using clip interrogators. Basically, given an image, give me the text. Given a text, give me an image. Given a text, give me more text. And then given a text, give me a graph. And then we have this whole multi-modal way of representing or explicitly representing architecture. And then we do the standard stuff. Topic modeling with the text. We do sort of the taxonomical generation based on the graph relationship and so on and so forth, or documents. Yeah. And then eventually we also managed to sort of categorize the projects. And the earlier result was shown to Patrick, and he was actually quite convinced that, okay, it does seem quite true, your categories. It's not really sort of, out of the moon, out of the complete, irrelevant. So that was encouraging. Of course, the project subsequently suffered much from an administrative problem between the SUTD legal office and so on and so forth. Disagreement or whatever. But anyway, I hope that the project will come back soon again. But for now, I won't talk about the MVRDV project, but it's still going on. So we're working with the MVRDV Next team. We're trying to represent their project because they have a very strong vocabulary, right? They describe their buildings as pixels building, as valley and whatever. So we can actually learn the relationship between words and form. So now we're working on something to train a model that could represent all their families, whether synthetic or real data, but very much in progress. So I just want to show this project because it's more at an urban scale. So this project was for 2.5 years, and really looking at is for the government, so very different. Have to be responsible and more serious about this. So essentially, they want a model. Actually, they didn't say a model, but we reckon that we need an AI model. That given any plan that's being submitted, design development control plan, we want to know if it complies with the regulation, even if it's a subset of it. We also want to know there is potential issue under 5 minutes. So if you try to do agent-based modeling for mobility tests, 5 minutes is impossible. So then we train an AI model because then it can infer based on this sort of a surrogate way of thinking about the agent-based. In the end, we didn't use agent-based. We use a graph neural networks where we predict every node in that graph. So the beauty of this project is that we actually combine the graph representation of the neighborhood, 400 or 800 radius, and the of the building. So you have this global local graph computation and allows you to actually predict which entrance or corridor of the building is quite likely given a particular day in time, while being informed of the neighborhood situation. So if there's a fire somewhere else, theoretically, somewhere else would be less crowded or more crowded. Anyway, so next, just to make sure I'm keeping in time, is the implicit perception prediction. So Carl Friston is known for this idea of the active inference. So essentially the whole, in a very simple way of saying, is that what you perceive is actually what you predict first. So you first look at something by thinking it's something before you see it as something. Like, it's not a simple input-output. It's this prediction, perception of an observation. And in a way, it's interesting because your brain is trying to reduce the level of discrepancy. Just like when you look at a friend, look at someone, and you thought, this person looked like my friend from my primary school. And as you walk closer, he's turned out to be not the one. So there's a huge loss to compute. And in life, we create our world with the computation of reducing these losses. Because we want to match the word that we have in our brain and the word that's out there. But anyway, you have time, you can read it. But how to actually use it relevantly. So in this case, again, using the Villa Savoye as an example, one project actually looks at, given a 3D object in AR, could you tell me which is the part that you will likely look at? And look at in a way that because you dislike it, or you love it. So to know whether you dislike it or... So essentially this is a point cloud segmentation problem, right? Given the set of point clouds, which are the points in the point cloud that says there's a high saliency score, there's a high likelihood that this is the part that you will look at all the time, or most of the time, and which are the parts that you will not look at. So this simple diagram try to explain this, right? Given a 3D model, can we compute the attention map of the model? So in order to know if you like or dislike something, we have to do something here. In order to know where you're looking at, we need something here, which is the eye tracking thing. In this case, the desktop version. We recently acquired a very expensive headset that synchronized the EEG measurement with the eye tracking. It actually arrived just a month ago. We're still playing with it. So the brain part is that we could actually have a sense of if you like something or dislike something based on the asymmetry of the frontal asymmetry visual cortex. And this is a spectrogram to represent the nodes. So this is interesting because that means I could do like a architecture to brainwaves pattern or a brainwave pattern to given the brainwave pattern, can I generate architecture? Well, actually, theoretically it's possible, and we presented this idea at the AAAI, which is the Advancement of Artificial Intelligence conference, and was published. Completely not about architecture, but it's about AI. And so what we did here in this project is to train 4 different models. Given an architecture view, interior, measure what you're looking at, measure what you're thinking, and then train a model that given either one, you could generate the other one. So from a prediction model to a generative model. Right, so anyway, so this is, it was quite old, 2023, though done in 2022, end of the year, December, but only presented in 2023. So if you think about it, that means it's actually possible if everyone has 4 different AI models or whatever, that trying to predict the ways in which you see things and think about things, you could create your own personalized metaverse, where any point in time, object will be replaced. So meaning, if I look at an apple, it triggers the same wave pattern or gaze map pattern as a pear, as a durian, let's say. At any point in time in that metaverse, these things will be swapped. And this is interesting because suddenly a metaverse can actually be personal in a way, at least in an interactive way. And we actually apply this idea and work with a furniture company called Ipsa Ipsum. And we look at all their entire product line. He wants to know whether people like it or not, but for us, it's not. The inquiry is the research is to say, can we do a design from the product first? So we developed this app where you can choose any objects, any stuff, and then you would generate the output, the whole interior design for you. It was not that common in those days, 2023, to do outpainting. So it's based on the outpainting concept. So here I'm basically trying to show is that you could actually generate anything, right, that will look right. We had this is the app. We had some problem because this company was the one that did the Crazy Rich Asian film. They create the palm tree, lamp, and our model struggled because it thinks it's a tree. It's not a lamp. So a lampshade, yeah. So very interesting. And we don't always have to use neural networks. Sometimes we also want to look at how, in the past, people have tried to measure aesthetics. So Birkhoff aesthetic measure is very famous. It's basically measuring the relationship between order and complexity. So which